Good morning. My name is Ray Kirk. I started at Apteco 15 years ago, developing the decision tree and modeling environment, then worked on PeopleStage, and now I'm bringing the two elements together under the banner of AI, which could stand for artificial intelligence or Apteco Intelligence, or listening to Hannah Fry's talk yesterday, augmented intelligence is perhaps a good way of looking at it. And behavioural modelling is all about using some automation to help exploit your transactional data, turning it into action. Understanding the historic behaviour of particular customers so that you can recognise the same behaviour in current customers to influence their future behaviour by choosing the best marketing action. It enables you to exploit the transactional data, pinpointing customer level events and the preceding behaviour, and doing this in minutes when it used to take hours or days. So this morning we'll look at what is behavioural modelling, some of the benefits. The main section will be on how it works and a FastStats demo, and then an overview of the process and some of the future developments. The session is being recorded. You're on mute, so if you want to ask questions, then please do so on Zoom, and we'll try and get back to you at the end. And as I say, it's recorded, so you can always download and look at it afterwards. And there will also be some slides available. So behavioural modelling, it's all about your transactional data, taking this and letting you identify customers with a particular behaviour of interest, such as those who've responded or unsubscribed. It lets you then characterize what's different about their preceding behavior so that as you look forwards, you can recognize the same behaviors in current customers and so choose the best marketing action. And we use behavioral features to typify or characterize the behavior, and these feed into any modeling technique. So, for example, you could reduce lapse and unsubscribe rates by identifying common patterns leading up to the point in time when a customer has historically lapsed or unsubscribed. You could recognize common patterns in good supporters and then identify which supporters should be encouraged to make a further donation. And you can also use product level data, targeting customers based on the combination of products in their basket, for example. The challenge for marketing today is dealing with so many different sources of transactional data. In the demo, we'll look at our holidays database, where we have bookings and the associated travel dates. Some customers also have an insurance policy. And then we have a new table of activities of things people did while on holiday. There's the communication level data as well. And the challenge is to take this timeline of events and to make sense of them and then choose the most appropriate action. So in our data, the booking date relates to the upcoming travel. Some people take out an insurance policy for this travel, and that choice may be influenced by the activities that the individual has planned for their holiday. And the example we'll look at today is whether to promote insurance for an upcoming travel. The benefit of behavioural modelling is that it enables marketing decisions to be made at scale that are driven by the current customer's behaviour. And this is enabled by simplifying the process of learning from historic behaviour. And the secret to this really is in the data processing, allowing you to explore and exploit your transactional data, developing, as I say, these behavioral features which can feed into any modeling technique and improve any modeling technique. We'll look at PWE today. And the benefit is that this exploration can be done in seconds and minutes when it used to take hours and days. So let's look at how behavioural modelling works, starting with some terminology and then going through the two stages, identifying the customers you're interested in and then exploring their behaviour, and then we'll look at an overview of the overall process. So reference dates are used to control which part of the historical timeline is being analysed. The training date is used to create a model based on historic data, the data before this predicting some event in the period after. The scoring date is used to apply the model to current data, using the data up to this point to make a prediction about what somebody will do. And then an evaluation date can also be used to check a model using historic data where a prediction can be made and then tested against some known outcomes. For a given reference point, the data, the training or evaluation date, the analysis and base selections are used to identify the customers. The analysis being those with the event you're wanting to predict, the people who responded or unsubscribed. And then the base selection includes the analysis, but also a backdrop of customers to compare against. In this example, it could be customers who are active at the point of the reference date. When identifying the analysis and base selections, in some situations, the focus of the analysis is the same period for all customers, for example, Christmas. So there is a single fixed point in time where the data before this can be used to predict who will respond after this date. In other situations, there's no single point in time that relates to, for example, when someone unsubscribes. So the behavior to be compared depends on when this event occurred for each customer. That's known as a dynamic or event-driven point in time. And these time points are aligned so that differences can be easily observed. Let's have a look then at how this works, looking at the first stage then of identifying the customers. In Q1, when behavioural modelling was introduced, this was with a fixed point in time. There were other developments, but coming up in Q4, we introduced the event-driven point in time, where the time is taken from the base event. In Q1, we'll extend that to use the analysis event too, and we'll see what that means in a minute. For a fixed point in time model, the reference date, or which is the training or evaluation date, that acts as the fixed point in time and is used for all customers to compare their behaviour. The base selection looks backwards from this point and could be, for example, all active customers who purchased before that date. And the analysis selection looks forwards, customers who will purchase a product, for example, in the Christmas period. For the event-driven point in time, a reference date is still used to determine the broad date range used, training or evaluation. And then a base event occurring within a certain time frame is used to define the base selection. For example, customers who received a campaign within 3 months. The date of this event for each person defines their point in time. This time point is coming from the base event. The analysis selection depends on a further event occurring within a certain time after this. For example, customers who also bought a product within a month of receiving the campaign. And the time point is then used to compare behaviours, aligning these time points to highlight the differences. The second scenario, coming in Q1, is where the time point is taken from the analysis event, often a spontaneous customer action. So the base selection will simply identify a broad group of customers that we're looking at, perhaps those who are active. And then a specific customer event, such as purchasing a product or unsubscribing, that determines the analysis customers, and the date of this event determines the point in time. So we have a time point for the analysis customers to compare their behaviour, but the question is what time point should be used for the base customers to compare them against the analysis. So that will be a challenge for Q1 to solve, providing some options around that. In the meantime, let's have a look at Q4 and how we create a dynamic point in time using the base event. The scenario we'll look at takes our fictitious holidays database, asking who takes out insurance for the booking that they've just made. The base selection will be people who have a booking in the year before their reference date, before the training or evaluation. And then the analysis selection will be people who have an insurance policy or who took out insurance up to 3 months after this. And we'll test our predictions using a 2019 evaluation date, and then use the model to select people whose recent behaviour matches what we've learned about those who historically took out insurance. To define the base, we will use a simple bookings level selection to describe the base event, people who've taken out a booking within a time frame of a year, and then a simple insurance event of taking out personal injury insurance within 3 months of the booking. FastStats then will turn this information into a person level base selection, and will create a recency expression that represents the closest base event to the reference date. And that is the point in time then which is used to select the analysis customers, people who have taken out an insurance policy within 3 months. The selection for this analysis group is actually now selecting on dates across multiple transaction tables, something which is difficult to do, or has been difficult to do within FastStats. So the insurance policy date is being compared to the point in time, which is coming from the date of the last booking on the bookings table. So let me just switch across to FastStats, and we'll have a look at how we set up the selections. So this is our holidays database. We have the person table with bookings, policies, communications, other transactional tables, and against bookings we now have activities that somebody did on their holiday. The behavioural modelling is accessed within the modelling environment, a tool that's been in the product for a while, but there's now a new alternative to the standard modelling that has always been there, which is to now use behavioural modelling. This allows you then to specify the training date and optionally to specify an evaluation date. So as set up there, we'll just turn on some columns. As set up there, that is giving you the Q1 fixed point in time functionality. I'll refer back to that in a minute. For Q4, the event-driven functionality is simply turned on by this extra option here. We'll keep the same training and evaluation dates. Just label that so we can distinguish the two. And then to set up the selections, I've got here a person level selection, and this is what you would have needed in Q1. Here we've got a selection of people who've taken out insurance, and we have a forward-looking date selection. Drop that on, and that creates the analysis and also creates a default base selection. In Q4, we need a simple booking level and insurance level selection. So we'll use these to define our analysis and base. I'll drop those two onto the modeling environment. You'll see that they are categorized as event selections. I can use the booking event to create the base selection, people who have a booking within 1 year before the training date, and then use the insurance selection, combine that with the base to find people who took out a policy within 3 months after that booking. And FastStats has then, behind the scenes, created the analysis and base selections, and I can view a copy, and this is the selection that we saw in FastStats. So we'll come back to this in a minute and look at how we can then create the behavioural features. So I'll just go through how the behavioural features are set up, and each behavioural feature summarises some aspect of a customer's behaviour over a period of time. There's a common structure to each feature in that they all have a particular time period that they're analysing. You can optionally define criteria to say just look at transactions that match, say, a certain destination, for example. Then there's an aggregation function, a recency, frequency, or value function. By default, a count is used. And then you can optionally define further calculations, perhaps counting the proportion of transactions that match the criteria in that time frame, or the difference from the previous time frame. In defining criteria, you could use any variable that's on the transaction table. In our case, we have the booking destination. This then simply highlights those bookings, and then you can count those bookings that match that criteria within the time frame. Combination criteria were introduced in Q3, and these apply when you have a lower table below the transaction table. So, for example, products within a basket or web pages within a visit. And on our system, we have the new table of activities that people did on their holiday. You can then use a variable on this lower table, in our case, highlighting sports activities, and then define a combination criteria at the higher level, perhaps bookings which have only sports activities, and then count per person the number of bookings which then have that combination of activities. There are different types of combination that can be defined. So if we think of the combinations of red, green, and blue, you can have some of those colors, and this would allow others from the list, add others that are not on the list. If you say only red, green, and blue, then it must contain some of those items, but no others in addition. Every item from that list would also allow others too. Exactly red, green, and blue means no other items are allowed as well. None, self-explanatory. And then you can also define compound combinations. So the classic meal deal would be sort of some sandwich, some snack, and some drink, or you can use any of these types, perhaps identify people who haven't bought a drink with their meal. Calculations can be used to refine a behavioural feature, often providing some sort of context. So if we think of the customers who take insurance will tend to have perhaps bookings with sort of dangerous sports activities, we might expect customer 2 to be more likely to take insurance, seeing as they have 4 bookings matching that criteria. However, when you look in the context of how many bookings they take in total, the proportion would perhaps suggest that customer 1 might be more likely to take out insurance. So we'll have a look then within FastStats at how we set up these features. I'll just take a minute just to sort of preview what we'll actually do. We'll start by looking at which transaction types are predictive, looking at a count from each of the transaction tables. We'll then take forward the tables that look predictive, explore the time periods, using a recency function to take that a bit further, and then look at using criteria to refine the bookings features, using a calculation of a proportion to provide some context, and then use the activities table to create combinations and select bookings that match those that have some combination of adventure sports. And we'll end up with a list of features that we can then take through into our model. So back in FastStats, we can use the selections that we set up earlier, and now on the Dimensions tab, we can start looking at what are the differences between our analysis selection of people who took insurance compared to those who simply just booked a holiday. So I'll start by just creating a simple account feature to look at whether the number of bookings that people had taken previously makes them more or less likely to book insurance, or whether the number of activities someone has done makes a difference, or equally whether someone has had a previous insurance policy, whether that makes them more or less likely to take out insurance. As we build that, I'll just show you these other columns here that help evaluate these features. The mean PWE is calculated based on the training data and will help us to rank these features. And then the power figure is calculated on the evaluation data to show whether the learnings from the training data can be transferred across to a different time frame. So the mean PWE, if I just sort by that, that's based on the difference between the analysis and base groups. In blue here we have our base customers. So these are customers who have a booking in the year before the training date. And then we're seeing how many bookings they have prior to that point in time. And in green, we can see those who went on to take out insurance and can see that they have more previous bookings. The PWE metric compares those two groups and shows the differences. And a positive PWE relates to, shows the customers who are more likely to take out insurance and that they tend to have the higher number of previous bookings. And that same effect applies to activities and policies, showing that there's a sort of higher frequency of previous engagement with our business makes you more likely to take out insurance. That in itself isn't a great insight, but it's a starting point to show that these tables do have some relationship with whether you take insurance, and perhaps if we looked at other tables, they may be less related. So we can now extend these features and refine them further. If I right-click on the policy feature, I can explore whether the date of your insurance policy makes a difference. I can create a separate feature for each different time period individually, or in one click, create 5 new features, one for each of those time frames. And now FastStats is looking at just the day or week or month before someone's booking and seeing how many insurance policies they had taken out in that time, and whether that makes them more or less likely to book another insurance policy for their next holiday. The quarter before has the biggest impact or the biggest relationship, and this actually is a strong negative relationship. saying that people who have an insurance policy already in the month before, sorry, in the quarter before they make their booking, those people are less likely to take out another insurance policy. And that pattern also applies to the month, the week, and the day before. However, if you look back a whole year, we get the same sort of pattern that we were getting previously. The orange color showing that it's less significant because we've kind of got mixed in this conflicting opposite effect that makes you less likely to take out another policy. So I'll remove those less predictive features and stick with these two, and we'll take those forward into our model. There's a new option that's been provided in Q4 to create a recency aggregation, which will help us sort of combine these two effects by looking at the time since someone's last policy. There's also a general recency that actually lets you look at the cost or the value of those policies. But this will let us evaluate how long in days, or let's use months, how long in months it is since someone's last insurance policy, and if that makes them more or less likely to take out insurance. And that we can see has gone to the top of the list. People who have an insurance policy in the previous 3 months are less likely to take out another policy, whereas those who have policies longer ago are more likely. So that looks like a useful feature to keep in our model, and perhaps I'll actually use that and take out the other two, which are perhaps saying the same thing, and we'll just stick with the single feature. So we could refine that further using criteria, but I'll demonstrate the criteria using the bookings policy instead, the bookings feature. And here we could explore whether the continent that someone has visited makes a difference. And we could generate 5 features, 1 for each of the continents, add those 5 features. And now FastStats will look at the number of bookings to those specific destinations. Note that where we already have a result, FastStats isn't going to reprocess those, and equally where we've unticked these features, similarly they won't be evaluated further. So the number of bookings you've had to the Americas makes you more likely to take out insurance. That pattern is actually applying to each of the different continents, although Europe is looking slightly different. If you've had more bookings to Europe previously, you're less likely to take out insurance. However, the overall sort of frequency effect is kind of dominating these results and perhaps masking the difference between the different continents. And I could remove that to some extent if we calculate a proportion relative to the total for each continent. And actually I'll delete the features that are there and just replace them with the proportion. So this is going to scale the results between 0 and 1. And again, the processing behind the scenes is kept to a minimum. We already have the counts for each of these continents, so we don't need to reevaluate those. FastStats is simply assessing the proportion, like I say, the percentage from 0 to 1. And this now gives us quite a clear indication that people who have over 80% of their previous bookings to Europe are less likely to take out insurance, whereas for the other destinations, there's a positive relationship. The yellow is indicating that we don't have enough data for a significant result. So we could actually just select these and use this option here to combine the criteria essentially creating a single feature. I'll delete the individual ones. And we now have a single feature which represents the proportion of your non-European holidays that you've had previously. And that is more significant. Again, we've still got some orange and yellow where we don't have enough data, and we could use an option to create a banding. I won't do that now, but you could group together the bands. The last thing we'll look at then is creating a combination, and we'll start by exploring the activities that you can do on holiday. And these are the types of things that you can do on our fictitious holiday company. And we might wonder whether people who go fishing, let's just pick a few of these, fishing and pony trekking, do they take out insurance? Or perhaps it's more likely those who do water sports, skydiving, for example. And just to save time, I'll turn those directly into a proportion and remove the underlying features. So FastStats is now counting at that activity level to see whether the proportion of pony trekking or fishing activities you've done previously influences whether you take insurance. And then we'll use what we learned from this lower level to then create combinations at the booking level. You can speed up processing using sampling, as I'll talk through a bit later. So here we can see then the proportion of skydiving activities does have a positive influence. Similarly for water sports, those people are more likely to take insurance. Pony trekking and fishing, the yellow color showing that there's no significant relationship. So what I'm going to do is actually just remove those features now, given that we've got some learning from that, and instead now go to the booking level and create criteria using the combination of activities that people have done on their holiday. And then I can select the ones that we've seen, water sports, add some other ones that I have looked at previously. And basically we're going to create a combination. We'll just call this an adventure sport. And then we can turn that straight into a proportion. And this will then count how many bookings somebody's had, or the proportion of bookings where they undertook some adventure sport previously. And there's a strong positive relationship there. So given these features that we've created, what we could then do is use them in a model. So this is using functionality that's been in FastStats for a good while. And here we've copied through the selections that we have been looking at and copied the features, and are going to evaluate those for the 2018 training data. And this is going to reuse essentially a lot of the figures we've been seeing in the modeling environment, and we can see the relationships that we've already learned. That people who have a policy in the last month, they would get a very negative score, saying they're unlikely to take out insurance, whereas people with a high proportion of sports activities will get a positive score. I can turn those into a single score variable, banding this, and I will do this for the 2019 data. And just call this insurance 2019. So FastStats is now, first of all, refreshing those coefficients based on the 2018 data, and then it's going to now apply them to 2019. For each customer, it will look in 2019 to see when their holiday was, their holiday booking that was, and then with that as the point in time, it will look back prior to that booking and say, how many months was it since their last insurance policy? If they've just had an insurance policy, it will give them a negative score, and it will look at how many bookings they had prior to that 2019 booking, whether they're in a high proportion of sports activities, perhaps give them a positive score. So that's just finishing updating on the 2019 data, and if we click finish, and that has now created a new variable. If I go back to the modeling environment, this has been sort of monitoring what we've been doing in the profile, and we'll have collected here on the results tab the results of that model. And I can now evaluate that model and see that there is a positive power. It's predicting who took out insurance, and the model report, again, another feature that's been in FastStats for a while, will evaluate for 2019 and show us that if we were to target the top 4 or 5% of people based on their score, then we would have contacted 20% of the people who went on to take out insurance. So we can have confidence that we're targeting the right people with our model. So having created the model, let me just go through a few of the other parts of the process. As you're exploring the features, there's an option to view a copy of the expression that basically underlies each feature to help you understand what it's aggregating. There's also an option to view features in a data grid individually, or you can export all the features to see record level information, each person, their point in time, and details of each feature. As I mentioned, you can use sampling to speed up the processing, setting the number of analysis records, also the proportion, analysis to non-analysis if you want. And you get the same results, but just highlighting really the main relationships because it's working on a sample of the data. Then, as I showed just at the end, from the modeling environment, launching a profile and then creating using the wizard to create a score variable, first based on the evaluation data. And then what we would go on to do, given more time, is go back to the profile and use 2020 data to then make predictions, and this would create for us a variable, and we could pick the top scoring people in that variable and use them in our campaign. Here I've actually just taken that selection of people and looked at their features, just to confirm that the people with these high scores, they are the people who have a high proportion of adventure sports or a high proportion of non-European holidays. So you could confirm why they've been selected and then use them in your campaign. So let's just summarize and have a look to where behavioural modelling is going in the future. We've seen how you identify the customers with a behaviour of interest. That's going to be made more flexible, allowing you to use the analysis event and other options to drive those selections. The characterizing in terms of behavioural features will be extended to include other features such as counting the distinct product someone has bought, enabling the use of interactions between features. The association matrix, I didn't show it today, but that's an option that's been within the modelling environment for years. That will be extended to support the behavioural features. The decision tree, again, has been in the product for a good while. That will be extended to support behavioural features. And then the aim really is to move towards automating the process, dynamically banding the features to try and remove as we saw, the yellow and the orange less significant bands by grouping together the data. And then automating the actual choice of which features could be used in a model. And then making the integration with PeopleStage and Orbit smoother to give you an end-to-end process. So as we look to next year, it'd be great to have some more volunteers to work with. I've worked with a number of partners this year who have provided feedback on pre-release versions, and have also had a chance to steer the direction of the development. One example being the recency feature, which I was talking to a partner only in September about that, and that will be in the Q4 release. And ideally, we'd like you to provide anonymized access to some client data, which will be especially useful in the next stages of automating the process and ensuring that these approaches work with a wide variety of transactional data types as possible. So if you'd like to get involved, then please contact us either during this event or afterwards. And I look forward to working with some of you in the future. Now, we've probably got a minute or two if there are any questions. Otherwise, we'll get back to you after the event.
Thank you, Ray. No questions have come up in the chat, but if people wanted to contact you in the future regarding supporting and getting involved with this development, how would they do that?
I think if you contact the main Apteco email address, that's probably the easiest way, and that can then come through to me. I'm happy to have sort of direct contact with people. I have done that during this last year, but perhaps that's the easiest way just to get in touch.
Okay, thank you, Ray. There's a few nice comments coming through in the chat at the moment, which I suggest you have a look at before we close it. Some positive feedback there, but no questions. Thank you very much.
Okay, well, thank you very much all for attending the focus group. Be in touch with some of you in the future and enjoy the rest of the event. Thank you.